Addressing in data communications and networking. IP addressing. IP addressing is the process of assigning unique numerical labels, known as IP addresses, to devices on a network, enabling them to communicate. These addresses are essential for identifying and locating devices, allowing data to be routed to the correct destination. There are two versions of IP addressing. The first one is IPv4. IPv4 is the fourth version of the Internet Protocol, core protocol used for sending data across the Internet and other packet switch networks. It is the foundation for how devices are identified and locate each other on the Internet. IPv4 uses 32-bit addresses, often written in dotted decimal notation. For example, 192.168.1.1. IPv4 uses the concept of classes known as classful addressing. The address space is divided into 5 classes A, B, C, D, and E. You can refer to the table shown for the address class, ranges, default subnet mask, and also default subnet mask in slash notation. Each class has different block size and different number of blocks, and also for the different application purpose. You can refer to the table shown. Another version is IPv6. IPv6 is the successor to IPv4, offering a much larger address space because it used 128-bit to address the limitations of IPv4. So the table shown on the screen shows 3 aspects of comparison between IPv4 and IPv6. So the first one is address length. IPv4 consists of 32 bits address. IPv6 consists of 128 bits length. So they have different number of addresses. You can see for IPv4, we can say that we have around 4.3 billion IP addresses, and for IPv6, it could provide up to around 340 undecillion. Next, let's look at another term, static address. A static IP address is a unique numerical identifier assigned to a device on a network that remains constant and does not change over time. Static IPs are typically assigned manually by a network administrator or through the device network settings. Static IPs can be used for IP whitelisting, where only specific IPs are allowed to access a network or service. Next is dynamic address. Dynamic IP addresses are assigned automatically and can change periodically. Dynamic IPs are more efficient for home networks and devices that do not require a permanent fixed address. They are typically assigned by the Dynamic Host Configuration Protocol, DHCP, which automatically manages IP address assignment. Internet service providers can reuse a limited number of IP addresses by assigning them dynamically to multiple devices. This type of address is ideal for devices that frequently connect and disconnect from the network. Next is MAC address. MAC address is Media Access Control Address, is a unique 12-character identifier assigned to network devices like computers, printers, and smartphones. MAC addresses operate at the data link layer of the OSI model, which is responsible for physical-level communication between devices on the same network segment. It is used to identify devices on a local network, much like an IP address is used to identify devices on the Internet. MAC addresses are typically assigned by the manufacturer during the device production and are hard-coded into the device network interface card.